welcome to Oracle Database Best Practices on vSphere. My name is Kanan Mani. I work with VMware. I pretty much take care of Oracle solutions for VMware. My pretty much job is to make sure how Oracle can run effectively on a VMware VM. I have Brian Bowen, who's our customer speaker. He's going to talk about how successfully he virtualized Oracle Database on VMware and what are the benefits he has achieved. Okay, so there's a little disclaimer. I think you must have all seen it. So just for you to read. Then let's go to the agenda. So as I said, the customer is eMeter. So Brian Bowen is here. He's going to talk about Oracle Database on VMware, how he has virtualized successfully, right? And then we'll go about why deploy Oracle Database on VMware. Then we'll talk about workload characterization study, which we did with EMC and Cisco. And we will dive into the best practices and see exactly what are the best practices you need to follow for virtualizing Oracle Database on VMware. Then we'll talk about Oracle and support licensing. Don Sullivan is here, right here. He's going to talk about the support and licensing about Oracle, virtualizing Oracle on VMware. Then we'll end it. Okay? With that, I'll turn it over to Brian. And Brian, it's all yours.
All right. How's everybody doing today? So, like I said, my name is Brian Bond. I'm with eMeter Corporation. We're an enterprise software developer that designs and sells and supports very, very large installations of software for the utility industry worldwide. We do not make meters. We do not deploy meters. We have nothing to do with that thing growing on the side of your head because you have one on the side of your house. What we give you is the ability, as an end user customer, we give you the ability to see your power usage over time, be able to manipulate your bill, if you will, in certain areas. The larger piece of it is we support, again, very, very large power companies, water companies, gas companies throughout the world, and their ability to actually take that information that's coming in from multiple sites with meters. Instead, back in the days when there was once a month, so one database line per month. Well, now they're getting thousands upon thousands of database lines per customer per month, and their billing system can only handle one. So we're in there to help them with that and provide a very, very good analytic system for them. So we started looking at virtualizing Oracle a while back for multiple reasons. Obviously we have in-house apps that we use on a daily basis, on the entire company. And we're a very, very, very virtual-heavy company. We're virtualized first, have been from the onset. We only go to hardware when there is some completely stupid reason to do so. And Oracle was one of those reasons. Just like everybody else, we put Oracle on hardware because that's what you do. You put Oracle on hardware. So as we started looking at this, both from an internal application perspective, from a product perspective, we're an Oracle partner. We develop a product that ships around Oracle on multiple different platforms, AIX, Linux, and Windows. And the bigger problem for us started coming in our quote-unquote dev test environments, our training environments, our sales demo environments. And if any of you in here are a part of a business, if you can tell me that your sales demo that's available to your salespeople worldwide is not a production instance of something, you're an amazing person. Because I can guarantee you can usually take your financials offline more often than you can take that sales demo offline without getting hammered on it. Every time you send an email out, it's going to be offline for a couple hours. People freak out. So that was one piece for us, being able to manipulate that, migrate it across different data centers, that type of thing. And as we were going through this process, we realized we can do this with everything that we've got, no matter what type of application that it's serving up. So the problems we were trying to solve were very long lead times for spinning up new Oracle servers, whether it was an existing instance of something we already had that we were going to take and manipulate for another purpose, whether it was bring it up for a quick dev test, a POC, if you will, or we simply needed to expand the capacity of a particular type of system we had. Increasing the availability, being able to build in HA, being able to fail things over when things get weird, move on, move things to different sites, that type of thing. Usually when your hardware goes down, your hardware's just down. The next piece was pretty big for us in being able to provide deployment options to our end-user customers, the people we sell the product to. When you walk into the door of some of these very, very large corporations, some of them which are like small countries, they usually tell you how you're going to deliver the product to them. You don't get to tell them. And sometimes they'll tell you, I need 14 racks of IBM P-class, and I need whatever this. And sometimes they say, we're a fairly virtualized shop. We'd like to have this all running on a virtual machine. So we need to be able to support that going out the door. Hardware upgrade paths was another thing. We found that the time that it takes to actually upgrade a piece of hardware for whatever reason, hardware refresh, something new, better comes along, we want to increase the capacity on it, usually took a significant amount of time. Lots of downtime. You have to build the thing up first. You have to test it out. Then you have to do your migrations. Those kind of things got into problems. DR strategy. For a lot of this stuff, you don't have a DR strategy. Your DR strategy is it breaks and you fix it. Well, by having the DR strategies you can get with VMware, you're able to build some of that stuff in right out of the gate. Biggest one is reduce costs. I've got a ton of Oracle servers. A lot of them are totally over-provisioned on hardware. Well, I can over-provision them on VMware and fit a lot more of them on a box. So that was a pretty compelling factor for us. The slide's a little bit busy, but we'll start on the right-hand side over here. Little diagram, basically. So we started off with a few hosts, got them up and running, very, very, very low density just to get it going, improving, make sure we have our networking set up, just like we would in a physical environment. Make sure we have our networking set up properly, make sure we have our storage set up properly, our LUNs set up properly, whatever we're doing, and get everything ready to go. And started off with just, single storage shared storage pool. We immediately moved on from that once we've proven that out that works. And in the background, one guy is shoving Oracle servers back, into the environment faster than I can build storage for it. And okay, now we need to work on, DR and test replication. So what we did was we started using storage side replication for that. A little bit of scripting built on the servers, quiesce the database, quiesce the OS, take a storage in snapshot. I've immediately got a backup. That's better than most of my environments at that point in time. Then I immediately turn around and I can replicate that to another piece of storage locally on site. I can send that to anywhere else in the world, whatever else I need to do. I can turn around and develop with that. I can test a software update with that. Actually, which turned out to be a pretty big deal. We did have an instance while going through this where we did a simple OS update on one of the Oracle servers and completely fried it. And we reverted the snapshot and did it again. And then reverted the snapshot and did it again. And we're able to keep going. That was a pretty big piece of information for us that we just didn't have before in the physical world. Well, it'd take forever to do a backup on a physical host. And then being able to use a single management point to manage all these different servers, no matter where they were physically, which rack they were in, which data center they're in, where, whatever part of the world they're in. We all know those as benefits of virtualization. That's the reason we do it. It was a reason to do it here, too. The storage that I used for this, for the primary portion of this, a company called Pure Storage. They're flash-based storage. And they they implement an inline deduplication strategy similar to things like data domain and whatnot, where the information is deduped going forward. Using that technology, using these databases that are not all identical, we got a 7x data reduction on the actual amount of data written to the storage. And that translated out into higher throughputs, faster backup times, and my provisioning time was much faster. I was cloning on a particular system from the same storage to the same storage, from a template, from a live system, whatever it happens to be, happens very, very, very quickly. The other thing we found in this particular case, when we got into database read scenarios, when we were doing data warehousing, that the performance just went through the roof. Where SSD, 90% of your speed is from the read side, and that's what you're doing a vast majority of the time, significantly improved the performance of our systems in-house. So continue on with some more benefits here. First one was the single management point. We talked about that. I mean, we all know what that's about. That's why we virtualize, so we have one console. We all look at it across the world. We all see what's going on. We get alerts. We get alarms. Everything's great. System-based snapshots. Touched on it a little bit. Being able to take a manual snapshot of a system for whatever reason at any point in time is a huge benefit that I do not have on a physical server. I can't do it. If my OS is running on a hard drive, on a Dell or HP or whatever our system, I can't just copy it right now because I want to and be done in 10 seconds. The HA and DRS can't even imagine having done this without this. Running DRS across the cluster on these took all of those fears that I had around performance away. I've got a bunch of Oracle servers that do nothing a vast majority of the time and periodically get hit and beat up with data loads. I've got a whole bunch of Oracle servers that are busy, reasonably busy, all of the time, handling requests all day long. If you allow me to try to decide where those go, things get out of whack. Putting DRS in a fairly aggressive mode, these things start floating around without any recourse, on the end user systems, and I'm able to utilize those hosts very, very, very fully. I run them pretty hard, actually. I run them a little higher than I thought I would as far as percentages of resources being used. So that was a very, very nice thing. Reduced deployment time is just nuts. Being able to spin up a base Oracle install, for example, is, I'm done in minutes instead of having a guy down at the data center for weeks, days, flipping disks around. System portability. We're all moving to the cloud. Being able to take your database, move it over here, your database server, have it be there. One of the things we've been toying around with a little bit is follow the sun portability. We've got a couple of examples in-house where if we can literally move the data where it's needed over the course of the day and reduce the latencies for access of that could be of value to us. And that's something we're working on very hard. That's kind of the extreme portability example, if you will, but we really want to do that. Rapid replication and recovery. I don't have to recover databases very often. I'm trying to think of the last time I actually did have to recover a database. Matter of fact, I probably spend more time in the last 5 years recovering systems and databases for SOX compliance reasons to say that I can than actually doing them. But the times that I have done it has been really, really important. Somebody standing at my desk, somebody on the phone, screaming at me, when is the system going to come back online? We're hosed. Let's get this going. This gives me that ability to go very, very, very quickly. Thin provisioning and deduplication reduces my storage overhead significantly. Yeah, you don't have storage issues if you have physical servers because you've got 5 or 6 drives in there and you have way more storage on that than you need. Your database is off on shared storage. But that's 5, 6, 7, 8 less spinning spindles per system that I've got that I have to manage, that I have to go down and pull disks out and replace and wait for RAID to rebuild, which decreases the performance of the box. It's a management point that we all have. Taking that out of the loop makes a very, very, very big difference. We've leveraged every single one of these features quite heavily through this deployment. I don't think there's anything up here that we've leveraged that you haven't already leveraged for all of the other applications that you're running already, for all the other systems you deployed. It's just another system. It's another application. It's Exchange. It's SharePoint. It's whatever you want to call it. It just has a different name for it. So, like I said, DRS, vMotion. vMotion was interesting. I'm really looking forward to some of the new stuff in 5 with vMotion and storage vMotion. I think that's going to make this even better than it's already been for us. Templates and cloning, obviously. Resource reservations. I'm scared. I don't want to do this because it's resource intensive, blah, 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 blah. Well, by being able to speak to a particular administrator one-on-one, look, I'll tell you what I'll do. I'll reserve you a little more than I do everybody else. We'll look at it. We'll guarantee your performance. Come back in a week. We'll sit down and look at the graphs, and I'll show you that you actually don't need that much. And then we'll slide it back down, or even in some cases just remove them. Come back in another week, and we'll talk. Sometimes you do have to show people what's going on. But by being able to do that, you are able to, in some cases, allay a little bit of fears. Or, if you do have a machine that misbehaves regularly, make sure that it has enough resources that it can misbehave and keep it from using resources that it shouldn't be. Storage-based snapshots, again, quite a big deal for us. Our future plans. Biggest one for us, it was on a slide earlier, is to productize virtual Oracle installations. Be able to walk to customers and say, here's our product stack. How would you like that? I've got a little rack, I got a big rack, I got multiple racks, I got no racks. Where would you like that rack? Oh, we'd like that in Indo-Asia. There you go. We can put it there for you. That's a big thing for us. For me, I don't got a problem doing this. But imagine walking into XYZ Power Company in Tennessee, big IBM shop, and telling them, by the way, we're going to virtualize the Oracle system this entire thing runs on. So you have to get over that hump with people and be able to productize it, get it out there enough, and get everybody on board with it. SRM deployments. Currently, we don't do full multi-site failover for our in-house stuff or for our product. There's value in that both from an in-house perspective, but from a product perspective, there's a very, very large value for that on us, and that's something we're looking at. Utilizing storage backends to be able to replicate data on the block level, deduped, and be able to spin those environments up anywhere we want to go. I think this may be a little bit where I might be able to get into my follow-the-sun forwarding of actual VMs. This might be one of the ways I'm able to do that. And that is it for my portion.
Thank you, Brian. All right, thanks, Brian. So let's look at why deploy Oracle database on VMware. So you all heard from Brian that what are the benefits he did by virtualizing, right? So number one would be Oracle licensing. So if you're going to consolidate, you probably want to go put entire Oracle VMs into a single ESX, and then you want to maximize the ESX server so that you can consolidate as much license as you can. Again, it depends upon the degree of consolidation, how much you're going to try to put. This helps you to save your Oracle licensing, right? And then the DB consolidation, as I say, how many VMs you can put, how many Oracle database VMs you can put on a ESX server. That, again, you can reduce your hardware cost pretty much by 50%, and you can consolidate servers as 4 times or 20 times, depending on your workload, or you can even overcommit it based on your workload. DB on demand, I think Brian covered pretty much about how do you deploy Oracle database, templatize, provide DB in DB server in a minute, right, for production as well as in a lab environment. And then the quality of service. I think he also covered about the high HA and simple disaster recovery he was doing it. So these are the critical, points you would probably want to consider for why you want to deploy Oracle on VMware. So let's look into this. I think you must have all seen, if you've already attended about vSphere, there's maximum scalability and performance with vSphere. We go from ESX 1, 2, 3, 4, and 5. So the 5 is the latest version. As you can see, we scaled up pretty much a CPU, right, from all the way from 1 to 2 CPUs to all the way to 32 CPUs on vSphere 5. Memory, it was less than 4 gig at ESX 1, right, 2 gigs per VM. And then you see 1,000 gig per VM, so about 1 terabyte, right? In the network, we were supporting from ESX1, we were less than 5 gig. And we went all the way up to greater than 36 gigs per second as of now. And then IOPS, I think we had this discussion in our previous group discussion, whoever attended it. So in ESX1, you can only do around less than 5,000 IOPS. So it scales all the way up to 1 million IOPS as of now with vSphere 5. So if your workload, you're thinking about if you're going to be, I think the average workload as of now, pretty much with Oracle deployment, somewhere around 2,000 to 5,000 IOPS per second. As you can see, this average VM can fit into this. Right? So let's talk about workload calculation study that we did with Cisco UCS and EMC. So this is a setup. This is architecture as you're seeing. We use 2 Cisco UCS blades. Each blade's they're having 2 sockets, 6 cores each. And we actually put the ESXi4 I actually on it, on both the servers, right? And we used a vCenter. And we also use a EMC Clarion CX240 as the storage. And for the network, we pretty much use 10 gig FCOE, the CNA card, the converged network card, which Cisco was offering. So, there's a link here which you can download the entire study, which I'm going to talk about it. Just want to make sure you want to mention that there's a study is available on public, which you can go download it. So let's talk about what was done. So these are the test scenarios we ran. So as you can see the scenario, we actually did a single scaling up a single instance database, single VM, single instance database. And then we also did a scaling out, we're putting multiple Oracle database in a single ESX server, right? And then we also did a live migration of the current of the Oracle database in a virtual machine, right? And we did a hot at CPU. So I think Brian covered some of the VMware features he was using it. So as you can see, vMotion is very critical for some of the customers who want to make sure without powering down your database, without powering down your VM, you can migrate your live running Oracle database server from one host to another host. And then hot at vCPU is again an excellent feature from VMware where you can add CPUs on the fly without powering down your database, without powering down your VM. And Oracle picks up the load, whatever the available resources, and try to process more workload. Okay, so let's look up on each scenario. So single virtual scale-up test, this is for the scale-up test. We actually put one VM here with 2 to 8 vCPU. We gave 8 to 32 gig of RAM. And then we had a swing bench which was running. Swing bench, by the way, it's a workload tool, which is actually from Oracle right now. I think a guy called Dominic Giles wrote it up. And it actually does a workload of OLTP and DSS. This was tested on the OLTP workload, which is a large-scale entry benchmark, which does a 60% read and 40% write. So as you can see, we actually did from 2 CPU, 4, 6, and 8. So we actually did for 8 because we were doing only 4.1. We were not doing testing on vSphere 5. The database size is pretty much about 1.1 terabyte database. For each VMs. And then we gave virtual memory 8, and then the SGA was 6 gig, and as you can see, 16 for the 4 CPU, and we gave 10, and then for 6 we gave 24, and then 16 for the SGA, and for 8 we kind of increased it to 32 and 20 for the SGA. So let's look at the storage layout, right? So you want to make sure the performance. So performance is the key here. You want to make sure your performance as compared to your physical, you want to make sure your storage is very key for it, right? You want to provide exactly whatever resources you provided for the physical server, you need to provide for your virtual server as well, right? So that way you can achieve the relative performance which you're trying to get it from a physical. So here, as you can see, this is the physical, the blue stack as you see. From the physical disk, and the physical disk, you provide a LUN, right, and you provide a RAID on top of it, and then you have this. You create a VM data store where you create a VMD case. I think in this case we have a VM Aura here for the VMs, and we have the data disk which is given to the Oracle data for Oracle data, and then we gave redo data stores for Oracle redo, and of course this is in turn created a VMDK, and we give it to Oracle ASM to manage it. You got it right. So this is how it has been. You need to make sure you lay out this properly in such a way you get the actual performance, a relative performance as compared to your physical. This is key. I mean, you have to really follow those guidelines. All right, so let's see what is the result we got it. This is the result we actually got it. So on an 8 CPU, we achieved about 145,000 transactions per second. And this is 4 CPU. We kind of linearly scaled up from all the way to 8 CPU. And here we get 500,000 of transactions per second here. All right. So let's see what was the CPU and I/O we actually got. So this is actually the IOPS we got on a single data line. You see the single data line, we got about close to about 1100 IOPS per second. And the CPU, as you see, it's about 800. You see 800 meaning it's an 8 CPU box. You see 800. So pretty much it's saturating the box. We are probably doing it about 99% use on the single EVM. So we are pretty much saturating the VM. Just to give an idea of how the VM was behaving. Was there a question? Yeah. Swing bench. Yes. Scale ordinary benchmark. So let's go to the next test. So this is the Oracle Scaleout test we did with multiple VMs, putting multiple Oracle database VM on a single ESX server, right? You're putting in this case, we put about 4 to 5 VMs on a single, almost 5 VMs. Yeah, we put about 5 VMs on a single ESX server. Each server are running 1 terabyte each. All right? So in this case, what we did was we actually set the memory for 16 gig and Oracle SDA to 10 gig, of course. And then we use the same two blade servers in this case. One blade server being used for all the swing bench. So each swing bench is actually trying to do load generate for each database servers. So let's see what's the layout here. So we are considering this is a departmental database. We are not running too much of workload. As you see this test 1, we are doing a production kind of workload. Here, it's a departmental kind of database. You're not really concerned about performance. So what you could do is you can consolidate. You can put multiple. In this case, you see that is. If I go back one more slide, just want to give you an example of how it was done. Here, you're just only giving one of those VMDKs here, right, for the single VM. And if you go to consolidation mode, you see we carved out about 5 individual VMDKs, and we gave each VMDK to each VMs, right? So in this case, the performance was okay. It's a departmental database. You can try to consolidate as much VMs as you can, and you can carve out as many VMDKs as you can on a single LUN. So again, as you can see, it's pretty much the same thing. We give the spindles, and then we give the LUNs as a RAID 1 plus 0 for your redo, and RAID 5 for your data disk, and RAID 1 plus 0 for your Oracle VM disk, the root disk. And then, which in turn, we carved out VMware data stores, and then we broke up into all multiple VMDKs, which in turn, the VMDK was assigned to the Oracle ASM, and then Oracle takes care of managing the files. All right? So let's look at the test result, what we got. So this, as you can see, we almost put 5 VMs. So the more the VM you put, you're trying to get lesser kind of VM transactions per minute. So on a single VM, we did about 150,000, right? And then if you put 2 of them, you are getting about 110 each. And these are all breakup of each VM. So 3 VMs was doing 101. In this case, 4 VM was doing about 98,000 IOPS. Transactions per minute, and then all 5 VMs were around about close to about 93,000 on each of them. So you get the picture, right? So how do you want to consolidate based on your workload? You probably want to size it and try to run it on your lab or on your dev test environment, trying to make sure this is applicable to you. Yes, sir. Absolutely.
So you're showing that even in 4.1, the multi-threaded capability of the underlying VM kernel is spreading your load across, giving you your maximum use of your CPU or of your resource underneath to it.
Yes.
Which is very important because this is very new. In previous versions, we didn't get this same linear
Got it. That's a good point. Yeah, yes. Do you want to talk to us, sir? Sorry. He was actually talking.
It's more of a comment to talk about if you add up in column 5, we see we're getting close to the 500,000 IOPS that we saw in the one large test. And that shows that in 4.1, not even just 5.0, but 4.1, we're getting a very linear scale across the multi-threading capability of the VM kernel using the resources. In 3.5, I would see some things that didn't scale as linearly, and this is a great test. But the question I would have is, you spent a lot of time thinking about your storage provisioning
and
using ASM here.
Yes.
Can you talk a little bit about, did you change your storage, or maybe later you'll say, here are some things in the storage that will get you and prevent this from happening because you'll overload the LVM component, your VMFS file system, improperly.
So this was probably whatever the available storage we had. We actually maxing out the storage what was given to us. We could have gone more than what you are trying to say. We could have gone more than up. So we actually have to only have room for only 5 VMs, where we can go up to only 5 VMs as of now. But if we would have had more storage, we could have gone up more based on the consolidation. So storage was a limiting factor over there. Yes, sir.
What happens when the CPU loads aren't even like that? With the scheduling, I've seen that if I've got something that comes in wants 8 CPUs, something that comes in wants 2 CPUs, all of a sudden the scheduling you lose that linear scale if you don't have common size blocks.
Can you repeat the question again? I'm sorry about it.
So if I've got an Oracle database with 8 virtual CPUs, another one with 2, the scheduler goes and says, I need 8, and so it has to kick everybody out to get that, and then you get the 2 comes in, I can't fit the 8 in, and there's the scheduling problems. It's really easy to get that kind of scalability when you're using exact same size Oracle instances. If they are disparate, you don't get that linear.
Oh, I agree. I totally agree. So, okay, sure, yeah. So what he's saying is, go ahead, boss. Yeah, this is Vas Mitra, by the way. Yeah, good. Thanks, Vas. Does that answer your question? Okay, cool. So moving on. So let's talk about the vMotion. You all know what does vMotion drive? It's like a zero downtime maintenance. You can migrate live databases, right? There's a little impact to the users during vMotion, right? So the point is how DBA do without vMotion, right? DBAs feel like, okay, vMotion is really great, right? You can take down the ESX server for maintenance. You can probably vMotion it over to the other ESX server, right? So let's see this. Since you guys already know about vMotion, let's see how this is done with the vMotion testing, what we have done on this test. Okay, so what we did was, on this here you see a 250,000 transactions per minute, which was running a live database with 4 CPU and 16 gig of RAM. So during vMotion, the first red line, what you're talking about, the migration start. So during vMotion, it just drops a little bit, and then once the vMotion, it's actually less than a minute. When the migration ends, your transaction peaks back, and then it comes back. It actually goes even a little higher. So you get the picture, right? So during only with the vMotion, there's a little impact and it's a matter of less than a minute, and then your transaction climbs back up after vMotion. Yes, sir.
What's the size of the VM? The memory size?
16 gig. It's right here. You're welcome. So that's the vMotion test. So let's see about hot add capacity, right? The hot add capacity is you hot add your CPU or memory on the fly when the VM is running. In this case, we did hot add the CPU. We pretty much added a CPU hot add when the VM is running. So what you can see is your latency is actually going up. You want to make sure your latency to come down, so you probably added extra CPU so that your latency is coming down, and your TPS goes pretty much flat, right? So let's see what was done. What was the test we were done with the hot add CPU? In this case, we use 11G R2 database server, 2 vCPU initially, right, with 8 gig of RAM. And then the guest OS is SUSE Enterprise Linux 11X, 64 guest operating system, with a VMware hot add feature. So you can see the red line again. Before hot add, you see the transaction about 80,000 per minute, right, before hot add. Once you do the hot add, you don't have to power it down your database server. You don't have to shut down your database server. You don't have to shut down your VM server. You just add it up. As the OS is aware of the additional 2 vCPUs being added, once the OS recognizes the 2 vCPU, Oracle in turn takes care of it. Oracle knows that there's a 2 CPUs there. It takes the 2 CPU and processes more workload, right? So as you can see, we are added a CPU extra, and you can see the transaction per minute goes up. It's pretty much like, it actually climbs up really well, and then you get the picture, right? Yes, ma'am. No, you don't. There's a feature called hot add. I mean, if you're on the VM, you can just go right-click, edit properties. If you go to the CPU and you say add CPU or add memory. And it is enabled as per the support of the operating system. In this case, SUSE has the hot add capability where you can go add CPU or memory together. Yeah, RHEL has that too. Yeah. Say again? Yeah, they have to, yeah. Okay, so I think we've seen all this testing, right? We saw scaling up the VM on a single VM, and then we also saw putting multiple databases on a single ESX server. We saw vMotion, we saw hot add, right? That's a test we did. And we also did Oracle RAC on a vSphere. So I just want to really quickly cover just the vMotion test we did with the Oracle RAC. So see, as you see here, we have a 4-node RAC. Each node is running on an individual ESX server. These are the Blade servers, Cisco UCS Blade servers. You see the 12-core, 192 gig of RAM. It has been listed like ESX1 through all the way ESX4. The RAC nodes are being like RAC 1 through all the way 4, and each RAC node has 8 vCPU. The memory we use about 64 gig of RAM, and we configured Oracle SGA to 40 gig of Oracle SGA, right? So this gives if you in a physical world, if you want to do a firmware upgrade to your hardware, you probably have to shut down that instance and then bring it down totally the instance, and then again you have to make sure you do the firmware, and then again bring it back, and then make sure you start the Oracle instance. Oracle actually see that if the instance is coming up, it's going to add it up, right? So in this case, we actually did a vMotion. If you do a vMotion from one ESX server, another ESX server, let me show you exactly what was done. So step 1, what we are doing is we are trying to migrate Oracle RAC node from VMware RAC from ESX2, which is right here. We migrated over to this guy, right? So in this use case, I've been saying that we're taking down this ESX server for firmware upgrade. All the VMs are running around 50% of CPU utilized here in this case. All right? So once you have done your firmware upgrade, and then what you can do is you can migrate back from 4 all the way to here, and you're done. So this is only possible with VMware so far. I mean, if you want to make sure without powering down the instance, right? Without not bringing down the instance. Yes, sir.
So supposedly with Oracle RAC physical, you can also do hardware shutdown and have your failover, things like that.
You could fail over, but what happens, the users which is there connected to that particular instance, the users have to go away, right? Or they have to fail over to the other instances. In this case, you don't have to shut down those users on that particular instance, right? They probably have a minimal impact during the vMotion, but it comes back up. Yes, sir. Oracle RAC on vCloud? As of now, we have not tested it out, but we will. Is that you want to run it on a vCloud? You said, right? Yeah. I mean, on the VCD, you mean? This is running on a vSphere 5, vSphere 4.1. I mean, not a vCloud. It's not support. It is. Yes. Okay, it is. Yeah. So with Lab Manager, yes, it is supported. We are going to VCD. You would, yes. Is that answer your question, or I mean? Oracle RAC. Oh, you mean running an Oracle vCloud database on a RAC that you're talking about? Yeah. So that is on the VCD. The VCD has its own database, which you can put it on Oracle RAC. This is what you're talking about, deploying Oracle RAC on a VMware. You got the picture? There's a VCD as a database, and they have the support statement where you can put, your VCD has an Oracle database, right? That is only supported as of now. It's single instance. The RAC is not supported as of yet. Right? You got it? Okay. All right. So let's look at the best practices, okay? Let's talk about best practices. So the general best practices as of now, you probably want to make sure you create your computing environment optimized for vSphere, right? Enable required settings like BIOS, make sure you enable VT, turbo mode, hyperthreading, right? And disable unnecessary foreground and background processor on the guest operating system. And you create golden images for optimized operating system using VMware cloning technologies. You probably can clone it. And then make sure you create an optimized golden image so that you can keep in place. You can repeat it by cloning it. And then we are saying our recommendation upgrade to ESX4. So, ESX5 as of now. But we are saying ESX4, you get about 10 to 20% of performance boost. If you're on a previous version, make sure you're getting a newer version. And allow vSphere to, the best virtual machine monitor based on the CPU and guest operating system. So, it is automatic. Make sure the virtual machine setting has to be selected as automatic so that you get a better, monitoring option, right? And then make sure you follow Oracle recommended best practices. Oracle has their own guidelines for all the KB articles, right? Which you need to follow it, right? And then for the time, sorry, my bad. So to minimize the time drift on our virtual machine, follow the guidelines of the KB article. There's a Linux guidelines. There is also a Windows guidelines. These are the KB articles which you need to probably ensure that there's a timekeeping is appropriate based on the guest operating system. For Linux, you follow this KB article. For Windows, you follow this KB article. All right? So this is the general best practices. On the CPU, you probably want to make sure you do not over-allocate CPU. I think Vas mentioned do not over-commit it unless your workload can allow it, right? Testing what we have done is pretty much we did not over-commit it. Pretty much gave 1-to-1 CPU so that you get a better optimized performance. And then if you don't know your workload, make sure you start with less vCPUs and then increase it later. If based on the workload you see it, okay, I need more CPU or more memory, try to gradually increase it. And then for larger workloads, we want to make sure the total number of vCPU assigned to a VM should be less than or equal to the total number of cores on an ESX server. This is what we're saying. We do not want to overcommit. Make sure it is within the limit of your cores, right? And then this is also a key. As I said, we can overcommit it if you know your workload, right? Once you know the workload, you can always overcommit it, and so that you can maximize the licensing feature as well. We probably want to make sure we avoid remote NUMA access. So make sure your vCPU on the cores, right, and also they all fall into a single NUMA node rather than moving into the next NUMA node. So that way you will do a remote access, which is actually have a little minimal performance impact. They call it like a wide VM, but we want to make sure we restrict into a single NUMA node rather than going to a remote one. Then hyper-threading. You probably want to make sure you enable your hyper-threading, but as you know, hyper-threading does not provide a full power of a physical core, it's just a thread, right? You want to make sure it gives you a little performance boost, but you shouldn't consider more like you should get a performance of a single core rather than a single thread. So that's on the CPU. Now let's talk about the memory. So memory, again, we want to make sure do not overcommit memory, right? Until we see a report that there's a steady state usage is below the amount of physical server memory of the server. So do not overcommit unless you see this. And do not disable the balloon driver. This is get installed on when you install VMware tools. And this is also a key. For Oracle, you want to make sure set the memory reservation to SGA plus the operating system. You probably want to make sure your configured memory and reservation memory may be the same. And you want to make sure you allocate enough SGA and also add your OS memory as well. So then set the CPU and MM virtualization option to be automatic so that vSphere can choose the best VMM monitor, right? So that needs to be set, which we talked about it in the CPU as well. And it applies for memory as well. And use large memory pages. I think we probably want to make sure for Oracle, you probably want to use large memory pages so that you can get an advantage of setting it up. Make sure you consult Oracle admin guide for sizing SGA as well. So to avoid remote memory access, size the VM to be less than the memory per NUMA node. So if a NUMA node has a 16 gig of memory, make sure your VM is less than a 16 gig of memory so that you avoid the remote NUMA access of memory. All right? So this is to give you a high level of what the memory is. So you have a client sessions here, you have a main memory for SGA, the operating system. This is why I said you have to probably make sure you account all this memory so that you allocate it, this total memory so that your VM is sized properly, right? Otherwise, you will probably access the disk, you will do paging and all those stuff and all. So we don't want to do that. Set the memory reservation to protect this. So that's about the memory, and then let's do the network best practices. So you want to make sure for network, you probably want to isolate the network traffic and the management traffic separately. So you don't want to mix and put the infrastructure and as well as the network traffic, as well as the VM traffic into the same network. You probably want to isolate it. Separate it with a different switch, different network. Right? And use network teaming whenever is applicable. Make sure you do teaming for availability and load balancing. And then take advantage of network I/O control to converge network and storage traffic on a 10 gig Ethernet. So there's a network I/O control feature which is available with vSphere where you can limit the bandwidth of my VM only can see this much of MBs per second. You can limit it. And then this is a this is a recommendation we always say. We use VMX Net 3. VMX Net 3 for the network. You have to make sure you install VMware tools so that you can get the drivers for VMX Net 3. Right? So this actually we have seen it increases the performance. You don't want to use a default E1000 or other drivers. You probably want to make sure you get the VMX Net 3 configured. Right? So as I said, it enables with the VMware tools. You get the drivers so that you can enable it. All right, storage. I think we have seen this. So we want to make sure you get the picture of the storage. You have the physical disk, you have storage LUNs, and then based on the LUNs, you carve out the data stored, and then on the data store, you carve out a VMDK, and then VMDK you assign into the VMs, and those VMs probably get assigned to the ASM pool where Oracle takes care of it with all those managed files. All right, storage best practices. So use vSphere VMFS for single instance or Oracle database deployment. This is actually good for even RAC as well right now. As you have seen, we have deployed Oracle RAC on VMFS as well as of now. So you can take advantage of VMFS because VMFS gives you all the features of VMware inbuilt, right? You can do vMotion, all other stuff features as well. So we want to make sure we use the VMFS. And it is proven. And it gives you equal performance of your RDM as well. And then use for IP-based storage, make sure you use iSCSI NFS, and you enable Jumbo frames. So we advise that. And then create dedicated data store to service database workload. So for a high workload demanding database, you probably want to make sure you dedicate the data stores for that. We have seen for a single VM scaling, we gave dedicated LUNs for the Oracle data to process, right? So we want to make sure you give a dedicated data source for the high performance workload. And then use Oracle ASM, which is actually Oracle recommends to use Oracle ASM, and we also recommend to use Oracle ASM so that Oracle manages the file effectively. And follow storage vendor best practices. This is pretty much key. Like whatever the storage may be, make sure you talk to your storage vendor and ask them how do you lay out your Oracle or any other database. In this case, Oracle database. Make sure they have a best practices for Oracle, how to lay out the disk and all those stuff, which is applicable for even for physical as well. And on the para-virtualized PV SCSI adapters, we recommend to use PV SCSI. This again get enabled when you install our VMware tools. So with the VMware tools, you can enable para-virtualized SCSI, and we want to make sure for database on redo, right, which I mentioned before, we have to make sure you enable SCSI adapters for those guys so that you get a better performance throughput. And then on the VMF data storage, you probably want to format the VMDK so that it becomes an eager 0 thick, so you pre-format everything so that you get a better performance as well. So we recommend to do an eager 0 thick. And last, we want to use multiple SCSI adapters to evenly distribute target devices. So if you want to create a single SCSI target, you probably want to make sure you create multiple SCSI targets. In this case, to give an example, for SCSI 1: you probably want to make sure you create a root disk. And then SCSI 2: you probably want to make sure you create the data disk. So that, and then for SCSI 3.0, and whatever it may be, you probably want to do redo. So there are about 4 SCSI channels which is available for VM. You want to make sure you effectively distribute all those adapters so that you can get a maximum throughput. All right. So let's talk about Oracle support and licensing. So with this point, I think I will probably turn over to Don Sullivan, who can probably talk about the Oracle support and licensing. So he's pretty much live and breathe with the Oracle support and licensing. So let me introduce Don Sullivan.
Hi. This is something you want to talk about at 6 o'clock in the evening in Vegas, right?
I know.
I don't know exactly how I wound up getting those labels. I'm pretty much a technical guy, but this becomes a pretty important discussion. The answer for support is yes, and you really don't really need to know a lot more than that, to be honest. There is a lot of spin, a lot of FUD around support from Oracle Corporation. The fact is that without an explicit statement of non-support, which does exist for a few sort of on the fringe applications, certainly did exist for Oracle RAC prior to 11.202, there is complete support. The support statement that you may or may not be familiar with, kind of knows the MetaLink number by heart, simply says that under the circumstances that they're unable to relate a particular problem that you present to a known bug, which, by the way, is a pretty hefty standard to fill. If you've done that, if you've actually run into an Oracle server bug that is not known at this point, and since there's around 72,000 plus known bugs even associated with 11.202, you've done something rather special. But let's assume you do something rather special, and it's not an application bug of some kind. It's a bug that they just have never seen before, and they believe that there's a problem with the hardware, because remember, vSphere is a platform of virtualized hardware. It's really no different than any other hardware that you've ever worked on. Right? Oracle certifies to the operating system level, not to hardware. Haven't for 33 years. Won't ever change that. Can't. Right? So under those circumstances, it has the Oracle instance, the Oracle software just has absolutely no idea of what kind of hardware it's running on, and it's not supposed to. Not in any real sense. So if you do run into a problem that they believe the hardware is at issue, just like any other hardware, they would force you to potentially re-platform that particular application on a different platform, whatever choice you made. Okay? So under those circumstances, if that were to happen, which we do have a couple of very rare examples in which that did happen, what we want you to really do in general is, if you have any trouble with support whatsoever, is open up a ticket with GSS, VMware support. Open up a ticket, Give us all the information, go through it, give us the SR. We're going to own it. We're going to own it through the TSA requirements. Basically what TSA says is that they have to take our calls, right? So we'll own it. We'll own it all the way through to its fruition. So if you have a problem with even an application that does have an explicit statement of non-support, go ahead and open up a ticket with us, and we'll help you re-platform that if it really were to come down to that, but it almost never does. So there really aren't any issues with this for the most part. We also have an entire Oracle global support team. So that means if you call up and you have a configuration problem for Oracle on VMware, RAC, non-RAC, doesn't matter, we're going to give you support in doing those configurations and actually figuring out the problems. Obviously, they're not out there writing patches for Oracle, but they are going to give you technical Oracle support. I work with them regularly. They're very good. So all of that being said, if you still have uncertainty about it, if you still have to talk to your management, or there's still that overriding problem that you want to be sure that Oracle is on board with this, we simply want you to consider the following. We will help you with this as well. I won't write this letter for you, but I can give you a set of talking points to include in a letter that obviously doing this on executive-to-executive basis is the best, to write a letter to Oracle to ask them to clarify the support position. Again, you pay them a lot of money for support, and this has been the rules for a long time. And you want to say to them, hey, Oracle, pay you a lot of money for support. We'd like to keep doing that. And we want to clarify under what specific circumstances will you not support us. If you get an OR 600, or if you get a problem in creating a data file, if you get an index invalidation of some kind in some partition somewhere, those are Oracle errors. Are you not going to support us under those circumstances? The answer is going to be yes. And you also, and we've had many customers do this, you can get explicit letters of support, and you can get them included in your contracts. And when you do that, and the customers who are willing to stand up and make these statements and push back a little bit, and who are prepared to have these discussions, get this done. So it's really not an issue, but a lot of times it gets spun that way. Okay? So, and we can go on with this for quite a while with lots of different examples. But I see a gentleman there with a Red Sox hat on, and I need to get to the Yankee-Red Sox game going on right now because I'm a big Yankee fan, unlike him. And I don't even know what the score is, which is very rare for me. So we can move on to this. Any questions specifically yet? Or we can talk to me after this event as well. Okay? Go ahead.
So let me try to go over about the Oracle licensing, so how it was structured as of now. So you see Standard Edition 1, Standard Edition, and then there's Enterprise Edition. So Standard Edition goes by license by socket. It doesn't matter how many cores you have in this. And then same thing goes with Standard Edition as well. Standard Edition 1 and 1 Edition, both are almost the same, right? They go by socket. The Enterprise Edition goes by the core, and they have a x86 factor. So if you have a single socket which has got 4 cores, so 4 cores times 0.5 factor, you only need 2 licenses for that. So we want to make sure you understand the Oracle licensing, all of the different versions, how it is being licensed, right? Yes, sir.
So, does this apply to the physical chip or to the CPUs?
Say again?
Does this apply to the physical CPU?
Physical CPU. It applies to physical CPU. It's on the ESX server.
So it's basically cheaper to run Oracle on VMware than to run on several physical servers.
So, what was the last thing you said? I couldn't hear you.
So it's basically cheaper to run Oracle on virtual machines.
It depends again. Yes, it depends how much consolidation you can throw it up. Like, as I said, if you can overcome it, if you based on your workload, you can throw in as much VM as you can. If you have licensed the entire host, you can put as much VM as you can so that you can maximize the licensing factor. Yes, if you want to do a vMotion, you have to license the whole cluster as well. Does that answer your question? Yeah. All right. So Oracle considers VMware as a soft partitioning. So that's how they're demanding us to license the entire host rather than licensing whatever being used. So that's how the definition of hard versus soft If it is hard, you can do a subsystem licensing. You can only pay for whatever you're using it. But in this case, we are soft partition, so it requires entire licensing. We advise the customers to make sure if they are trying to get a licensing for the entire server, make sure you put all the Oracle servers into that single ESX so that you can maximize the licensing cost. All right? So software technology, I talked about it. So this is the case which I think we were talking about it. So what if you want to do a migration from one host to another host? In this case, if you're trying to migrate from host 1 to host 2, make sure host 1 and host 2 are licensed, and make sure you put them into a logical cluster. Say in this case, the Oracle VM is migrated from host 1 to host 2, right? So the Oracle host must be licensed for all 8 cores. In this case, two hosts which are running 4 CPUs, right? You have like 8 cores on 2 blades. You probably need 8 cores times 0.5 factor. In this case, Oracle Enterprise is being used. So you probably need 4 licenses. So you can probably move from host 1 to host 2 because you already been licensed it. And again, make sure you group them into a single DRS cluster so that you can migrate it from ESX1 to ESX2 rather than migrating to host 3 and host 4. So you don't accidentally try to move your VMs from the non-licensed host. So that's something we always recommended, and also make sure you see the Gartner research ID, which actually offers a similar guidance like what was being said right now. Yeah.
Related specifically to this slide, if we're looking at this cluster, we've got the drawing as is. We've got maybe a couple of Oracle database servers running on one host.
Yes.
If we demotion all of the Oracle off that host onto another host,
yes.
What's our licensing then? Does the secondary host that we can go to have to be licensed?
Yes.
Even though it's not actually being utilized?
If it's part of the cluster, yes, you have to. Yes, sir. You could. Oracle doesn't know whether you're using as host affinity, but we don't recommend it because Oracle can, I don't know. Don, you want to talk about the host affinity?
Yeah, sure. So on the cluster level, there is no difference, right?
So we're a little over time, guys. I think if you guys want to stay, please feel free to stay.
Yeah, you can walk out on me. It's fine. I used to teach high school in New Jersey, so you know.
Sorry, Don.
The words in the licensing contracts and the pricing document are run or installed. All right? It doesn't say might run. And so many of our friends at the various different consulting companies really, really harp on those terms. I'm going to leave them alone for the most part. What we do recommend is the use of host affinity to create the subclusters that can be audited and guaranteed that no automatic operations are going to take those virtual machines running any of your Oracle or Oracle applications and move them outside that subcluster. Now, what I will tell you along the lines of the statement that I just made a couple of minutes ago is that, again, many companies, those that you would know off the top of your heads, if I could mention them, which I can't, I'm not even supposed to know about them because they're under strict NDA with Oracle, have host affinity recognized in their contracts, right? The Oracle does not reference it anywhere in its pricing guides in general until somebody mentions it. Keep in mind that sometimes the reps themselves don't understand the technology. They're not aware of it. They don't know what it really means. You might say, hey, I've got 4 nodes here, and they've got 8 cores on them each, and I want to keep licensing that, except I'm going to put it in this format, which is a virtualized infrastructure architecture, and I'm going to use this technology, and I'm going to guarantee this. And they might even be wanting to do some kind of audits at some point, and if they do, it won't be a problem because it's totally auditable. Now, you can, again, if you want to, really harp on the ideas and the terms of run or installed. But we have a way to make it a little bit cleaner with host affinity, I think. Okay? That makes sense? Don't try to go below the node level with the CPU pinning and the sub-capacity licensing. You're not going to win that argument. You're just not. I don't, so you're not probably either, right? But on a sub-cluster level, if you're prepared again and you're willing to push that point, get it written into your contracts. Others have. You will too. Okay?
Thanks, Don. So on summary, you get it, right? What are the benefits? You get it out. So you probably get server consolidation. You get rapid provisioning. You can do workload management. You can do high availability. You can do business continuity, right? So you get it. So pretty much like, I hope you got all whatever. I mean, we kind of talked about it. It's kind of really tough to digest all of this information. So we want to make sure we give it in a single session. So that's about it, guys. So summary-wise, like performance is not an issue. You have to, get immediate ROI by deploying Oracle database on vSphere. So you heard Brian talking about how much his company has achieved by going, from physical to virtual, right? And then use VMotion for your DRS to manage Oracle environment, right? Use hot add CPU this is a great feature, right? You can do hot add resources without restarting the Oracle database or the virtual machine. And do not leave your database non-virtualized or the business is exposed. Well, and again, virtualization should be a part of a customer compliance strategy. So for compliance, I think most of them are trying to go with virtualization, trying to make sure they adopt the compliance strategy so they can preserve the archived data. They can probably save it as a template. If there is any compliance audit, they can always show it back, right? And then, 249.212.1 is, as of now, so as I said, November 8, 2010 onwards, Oracle RAC is supported. So feel free to use that, and we do take support calls as well, as Don was mentioning. So with that, thank you very much. And then there's a VMware.com/Oracle, which has got all the resources available. It has a deployment guide, best practices, customer case studies, everything over there. And we also have blogs over there, which you can follow up, like what's going on as of now with virtualizing Oracle on VMware. Thanks a lot, and thank you very much for your time.